Let me say it directly. What we are seeing from this third interstellar object, 3I/Atlas, not only challenges every established physical model, but raises a frightening possibility. A message may be embedded within it, sent not through radio signals or binary codes, but through the material structure of the object itself. Its chemistry, its orbit, its behavior, everything about 3I/Atlas feels like a deliberate pattern waiting to be decoded. It all began when the Vera C. Rubin Observatory, the deepest survey system humanity has ever built, detected a new interstellar visitor racing into our solar system at almost unimaginable velocity. We classified it as 3I/Atlas, the third interstellar object ever observed, after Oumuamua and Borisov. But unlike its predecessors, 3I/Atlas breaks every expectation, as if it refuses to obey the rules of our cosmic neighborhood. From the very first orbital calculations, I knew something was wrong. If an object follows Newtonian gravity and Einstein's corrections, its path should align with the equations. But 3I/Atlas deviated, and not just slightly. The deviation was so large that even non-gravitational models like outgassing, which we used to explain the strange behavior of Oumuamua, simply collapsed. This object appears to be pushed or pulled by a distant, invisible force, one we cannot identify. Not solar wind, not radiation pressure, not surface sublimation. It moves as if it has been guided or programmed long ago toward a trajectory that does not originate in our stellar neighborhood. When we turned our strongest spectrographs toward it, things became even stranger. The surface of 3I/Atlas didn't behave like rock, ice, carbon-rich material, or any known category of cometary or asteroidal composition. Its spectrum displayed features so alien that I kept telling my colleagues, "Check the system again. This can't be ordinary matter." But the system wasn't wrong. The reflected wavelengths revealed a type of material unseen anywhere in the solar system. Sharp, narrow absorption peaks that shouldn't exist. It was as if the surface contained a super-heavy, ultra-stable substance, something our local universe shouldn't naturally produce. Early analysis led us to a shocking possibility. 3I/Atlas may contain material from the theoretical island of stability, an idea from nuclear physics predicting long-lived super-heavy elements. Among them, one candidate began to emerge as the most likely match, element 121, a nucleus so massive and exotic that even our most powerful particle accelerators have failed to create it. I remember the moment clearly. Elena Rossi, the astrophysicist leading the spectral analysis team, burst into the conference room, pale and shaking. She thrust her data sheets onto the table and said, "If this is real, then 3I/Atlas contains a stable isotope of element 121, something that cannot exist in our cosmic environment." What does that mean? It means the origin of 3I/Atlas isn't tied to any normal star system formation. If element 121 is truly present, the object must have been forged in an astrophysical event of unimaginable violence, far more extreme than a supernova, a place where neutrons compress matter beyond anything our universe typically produces. And yet, that isn't what keeps us awake at night. The real question, the one that froze me as I stared at the data, is this: why is a significant amount of element 121 sitting on the surface of an object now heading straight into our solar system? Is it merely a cosmic accident, or is it a material message, a kind of chemical handwriting from a region of space we have never explored? What message is it carrying? We don't know yet. 3I/Atlas is still approaching, and beneath its billion-year crust, I am convinced something else is hidden, something we may not be ready for. When the orbital anomaly of 3I/Atlas became undeniable, the world's observatories shifted into emergency mode. The James Webb Space Telescope, Keck, ALMA, and every ultraviolet-capable instrument were pointed toward this intruder racing through the darkness. We had a narrow window, just days, to capture the deepest spectra before Atlas swung past us forever. I remember the intensity in the control room. No one spoke above a whisper. It felt like we were eavesdropping on the universe itself. The first ultraviolet data arrived, and everything stopped. A razor-thin emission line at a wavelength no one recognized appeared on the screen. Too sharp, too clean, too isolated to be noise. It didn't belong to any known element on the periodic table. Not hydrogen, not helium, not iron, not any of the heavy R-process nuclei we had cataloged from supernovae or neutron star collisions. This line felt engineered, artificial in its precision, a signature that shouldn't exist. Elena Rossi stared at the monitors with trembling hands. She whispered, "This line isn't in any atomic database." I felt the same chill spreading through my spine. An unknown spectral fingerprint meant one thing: a new atomic structure, a new nucleus, a new element that our universe normally refuses to make. Teams across the world began running atomic simulations, trying to predict what kind of nuclear configuration could produce such a line. The models crashed repeatedly. Superheavy nuclei tend to decay instantly, tearing themselves apart in microseconds. Yet this spectral line was stable, coherent, persistent. Whatever produced it was not falling apart. 40 hours after the discovery, Elena slammed a stack of printouts onto my desk. "I think I know what the line belongs to," she said, "but you're not going to believe it." Her simulations pointed toward a stable isotope of element 121, unbiunium, long predicted but never observed. Our particle accelerators have strained for decades to reach beyond element 118. Attempts to create 119 and 120 produced only fleeting whispers of atoms that vanished before we could probe them. But 121? That would require a stability island so deep and so improbable that most physicists believed it existed only on paper. And yet 3I/Atlas carried it casually on its surface. The implications hit us like a tidal wave. Element 121 cannot form in stars like our Sun. It cannot form in red giants, white dwarfs, or typical supernova. To make it at all, nature needs an environment of unbelievable neutron density, something far more extreme than anything our region of the galaxy offers, an event capable of squeezing atomic nuclei until they cross a threshold beyond human reach. As the data accumulated, something even stranger emerged. The abundance pattern of the spectral lines wasn't random. The ratios of ultra-heavy peaks formed a repeating structure, a mathematical rhythm, as if 3I/Atlas carried not just exotic matter, but intentional arrangement, like encoded bars in a cosmic barcode. I couldn't help asking myself the forbidden question: if a civilization wanted to send a message across interstellar distances, one that could survive billions of years, radiation storms, and galactic drift, what better medium than the most stable superheavy nucleus in existence? What better messenger than an interstellar object designed to endure forever? 3I/Atlas wasn't just a rock. It was becoming clear it was something else, something built by physics we barely understand. And deeper inside, its meaning was only beginning to reveal itself. The question that haunted every scientist on the project was deceptively simple. Where in the universe could element 121 be forged? Not theoretically, not on paper, but in reality. The more we analyzed Atlas, the more impossible it became. A stable isotope of such an ultra-heavy element requires a birthplace far beyond the reach of ordinary cosmic events. Even supernovae, those titanic furnaces that create the gold in our jewelry and the iodine in our bodies, could not manufacture it. Their neutron flux wasn't high enough. Their pressure wasn't intense enough. So we turned to the only phenomenon violent enough to push nature beyond its own limits: neutron star mergers. Two dead stars, each the size of a city but heavier than the Sun, spiraling together in a death dance until they collide with the force of a billion supernovae. For years, theorists speculated that such collisions might briefly open a gateway into the deepest R-process regime, where nuclei are crammed with neutrons faster than they can decay, forming structures so massive that they border on the forbidden. But even then, element 121 should exist only for microseconds, fractions of microseconds. The idea that Atlas carried macroscopic quantities of it, enough to form visible spectral signatures, meant its origin had to be even more exotic. Its birth wasn't just the product of a merger. It had to come from the heart of a neutron-star merger whose conditions were pushed to extremes by a second factor, something we still don't understand, something that produced not just debris, but a new kind of cosmic matter that refused to decay. We began tracing Atlas's path through the galaxy, running its orbit backward through simulations that accounted for gravitational influences from stars, dark matter halos, and galactic tides. What we found only deepened the mystery. Atlas didn't come from any nearby star system. It didn't come from any known stellar nursery or cluster. Its trajectory pointed instead toward regions of the Milky Way that are almost inaccessible to observation, places where gravitational chaos reigns. The models converged on two possible origins: the galactic core or a dwarf galaxy long ago absorbed by the Milky Way. Either location would have hosted extreme astrophysical conditions, dense star fields, high neutron populations, and catastrophic mergers capable of producing exotic matter. And if Atlas came from a dwarf galaxy, it may have been drifting through interstellar space for billions of years before crossing paths with us. But there was a detail none of us could ignore: the presence of structured spectral ratios in the superheavy elements. Nature creates randomness, explosions, collisions, stellar death. They produce symmetric patterns governed by physics, not intent. But Atlas showed asymmetry, selection, repetition, as if the debris was sorted, curated, designed. It left us with a chilling possibility. Perhaps Atlas wasn't simply a shard from a cosmic catastrophe. Perhaps it was a preserved fragment, deliberately ejected from its original system, a relic carrying the chemistry of a world whose physics we barely recognize. If so, then the element 121 embedded in its crust wasn't just matter. It was a signature, a fingerprint, a message from a place born in fire so intense that even the laws of our universe bend. And we were only beginning to understand what that message implied. As we dug deeper into the spectral anomalies, another startling layer emerged, one that no one was prepared for. Beneath the superheavy signatures, hidden within the faintest mid-infrared harmonics, we detected something far more familiar and yet impossibly out of place: complex organic molecules. But these weren't the polycyclic aromatic hydrocarbons commonly found in cosmic dust. These molecules were larger, more intricate, with branching structures that suggested catalytic pathways unlike anything in our biochemical textbooks. What shocked us most was not their complexity, but their preservation. These molecules looked untouched by billions of years of cosmic radiation, solar winds, or ultraviolet bombardment. Something was protecting them. When we modeled the shielding effect of Atlas's crust, the answer became frighteningly clear. The presence of element 121 and other ultra-heavy isotopes wasn't just an exotic surface feature. It formed a perfect protective shell, a radiation armor so effective that no known material on Earth could match it. Under that shell, fragile organics could sleep undisturbed for geological timescales. It was as if Atlas had been wrapped in the strongest biological cryoshield the universe could offer. I remember staring at those models with a sense of awe and dread. A cometary body armored with superheavy elements, carrying organics preserved with absolute precision, drifting across galaxies for eons. If nature constructed this, it was performing a miracle. But if someone constructed it, intentionally or not, then this was something far more consequential. We began asking the most dangerous question in astrobiology: is Atlas a vector of panspermia? But not the traditional kind. This wasn't a random chunk of ice sprinkled with amino acids. This was a vessel hardened by ultra-heavy material, fortified to survive cosmic violence. A vessel designed, whether by nature's brutality or intentional engineering, to deliver intact chemistry across unfathomable distances. Some argued that calling it a vessel was exaggeration, that we were anthropomorphizing a cosmic accident. But the organics were not only intact, they were too intact. No thermal degradation, no isotopic fractionation. The ratios of carbon, nitrogen, and hydrogen remained eerily stable, as if frozen at the moment of their creation. Then came the discovery that broke the debate open. In several of the preserved organic clusters, the reactive centers, sites where Earth chemistry uses metals like iron or magnesium, were instead coordinated with ultra-heavy isotopes, not naturally radioactive, not unstable. These sites behave like biological catalysts, but with atomic properties that Earth-based life has never encountered. Biology using element 121 derivatives as cofactors, life built on a periodic table shifted into forbidden territory. The implications were staggering. If life could evolve in an environment where superheavy elements were stable and accessible, then its chemistry would be completely alien to ours, far more resistant, far more adaptable, shaped by radiation and neutron flux beyond our imagination. And if Atlas carried fragments of that chemistry, then it wasn't just delivering material from a distant star system. It was delivering a sample of an entire biochemical paradigm, tucked beneath a crust forged in the heart of a neutron-star collision. A paradigm that might reflect a world where physics itself plays by different rules. A paradigm we were now holding in our hands, still unsure of what message it was trying to send us. The moment the world learned about element 121 on 3, I/Atlas, everything changed. Physicists, biologists, philosophers, governments, everyone felt the same collective shiver. For the first time in human history, we were staring at matter that could not have formed in our cosmic neighborhood. A nuclear fingerprint from a world shaped by forces we do not possess. A biochemical hint from a periodic table we've never used. And beneath it all, the unsettling possibility that this object, this silent wanderer, carried a message encoded not in language, but in its very atoms. In physics, we often talk about paradigm shifts. Copernicus moved Earth out of the center. Einstein folded space and time together. Quantum theory shattered our intuition. But Atlas introduced a new kind of shift, one that didn't just rewrite theories, but challenged the assumption that our universe is chemically complete. If element 121 exists naturally elsewhere, then the periodic table we memorized in school is just a local dialect of a much broader cosmic language. Particle physicists around the globe were electrified. Laboratories began racing to synthesize stable superheavy nuclei, desperate to test whether the island of stability was not myth but map, one that Atlas had finally revealed. Funding surged. New accelerators were proposed. Entire research fields pivoted overnight. But even as the scientific world celebrated, another question loomed like a shadow. What if this wasn't just a discovery? What if it was an invitation? The structured abundance ratios in Atlas's spectral lines, the repeating mathematical rhythm no natural process should produce, kept pulling us back to the same suspicion. Someone somewhere might have understood the permanence of superheavy matter. They might have recognized that atoms can outlive civilizations, that chemistry can carry messages across galactic gulfs long after languages die. And if that's true, then Atlas is not merely a relic, it is a messenger, a cosmic artifact drifting through darkness, waiting for a mind capable of reading its atomic script. I find myself returning to the same thought. If life emerged in a place where element 121 was common, its evolution would be governed by different rules, different strengths, different vulnerabilities, a different relationship with time itself. So I leave you with the question we still do not dare answer. If Atlas comes from a world where superheavy chemistry is ordinary, what kind of beings rose alongside it? And more importantly, why did they send their message here?